Okay. So now I can now share my screen back to where we are before. Okay. So I believe every one of us can see my screen now. So I'm going back to SPSS. For me to open the data I'm looking for, I'll come to File, then I'll come to Open, as we have taught ourselves, then Data. Then the file is located at this document for me. So initially the system goes straight to where I have the data itself. So if you have yours in another different case or you don't see it, you can always come down to this Dropbox, then locate the directory. You have saved the data. So in my own case, I have saved the data on my desktop, and there's a folder I named, which is I named it as okay, training document for Eshadai. So then in that data, I have my SPSS. So you'll have ensure that the file type is in SPSS format. So assuming you are interested in Excel, so you change this to Excel. So that's how you can locate the file type you are trying to open. So since we are opening SPSS data file, so I don't have to change it. So it's then the other thing I will just do is to click open. So when you click open, the dialog box of the output you are going to be seeing first, but then you can change it to your data view, which I have here now. Now this is a set of data for 30 respondents on different questions, and these questions I already shared with us the questionnaire itself that has constituted this data. So, and if you are interested in knowing the parameters, the information of each of the questions, you can come to your variable view, in which you can try to fill what they have used as different sections. And secondly is that instead of you doing that, another way you can also do that is to just come to this symbol that has variables. If you click on these variables, you are going to, once you click on each of the questions, it's going to be giving you the various information that they constitute. So if I click on the second one, it gives me that these are the age range. And if I click on the second one, it's giving that that's position of the participant in the organization. Then the other one is giving me the years of experience. So if you want to know information of all the questions that are in this particular data, that is another areas you can get to know them. So you don't have to be going through the variable view and be trying to open them one by one, which is more somehow complex a little bit for you to digest each of the information. So at a glance, you can get to know all the informations on your data set by just clicking on the symbol I've clicked for us. Now, let's assume these are our data we have worked on and we're interested in performing some statistics analysis with it. Assuming I want to look at the descriptive statistics, when it comes to descriptive statistics, what are descriptive statistics? Descriptive statistics are these are some of the statistic techniques that has to do with mean, median, and likes. Those statistics are just looking at the characteristics of the information we're trying to bring out. So those descriptive statistics are statistics that doesn't require interpretations. So they are not inferential, because inferential statistics has to come with what we call with hypothesis, because you are going to be making conclusion, you are going to make inference on them. So it's like you are trying to test something in which you are proposing an hypothesis, or maybe you are trying to look at a particular observation in which you are looking at inference or impacts. So when we do these type of things, then we talk of inferential. But in summary, for discrete statistics, it's only we are looking at it to just know the properties, the characteristics, information of the data we are working with. So now, if you are interested in working on this data, and we are interested in looking at the discrete statistics, where do we get it? You want to calculate your mean, median, mode, and thereabout. How do you do that? So what we'll do is that you come to analyze. Everything you want to do under SPSS, in terms of analysis, everything is loaded at the analyze section. So when you come to analyze, you can see different things there for different purposes. But the ones that is specifically our own case is what we are going to do. So if you want to do some little analysis in terms of descriptives, where we are going to come in is just where you have the descriptive statistic. When you go to descriptive statistics, you see frequency, you see descriptives, you see explore, crosstabs, and like. So all these ones, I'm going to explain the ones that are most important to us. Frequency. When you click on frequency, frequencies is just when you click on it, That is when you are going to be seeing normal frequency and the percentage along with it. If you come to where we have descriptive will only just give you the summary statistics like the mean, median, the mode, the kurtosis, skewness, and those are descriptive. It will not give you frequency or percentage of the particular variables of your choice. So now explore. Explore will gives you all the parameters like frequency, mean, median, mode, kurtosis, skewness, all these things I've mentioned. But we use explore when you are trying to compare variables. I'm trying to look at interrelationship that is existing between variables, maybe a characteristics. Maybe, for example, now I pick sex. Maybe I'm looking at the comparison statistics, discrete statistics that's between sex and male and female. That's what we use explore for. So for those of us that are in the experimental classes, like all these veterinarians, all these food nutritionalists that do something that has to do with tests, that looks at something that has to do with distributions, or maybe they are interested in looking at some properties or to look at variations. Then they always make use of this explore so that to see at different stages or to look at the difference between a particular set and a particular set. So we use this. So that's just what we use explore for. Crosstabs. Initially, put this one under because there are some sections in which you are going to be seeing. For example, crosstabs. What you can do with crosstabs is that crosstab also is doing something that's doing with relationship. But when we talk of relationship, most of the time we look at relationships that are categorical in nature. If you are looking for chi-square, the original chi-square itself, PSC chi-square, it is at this crosstabs you are going to see it. So when we get there, or when I need it, I will explain further on that. So, and I think those four that were listed up are the ones that I'm going to be explaining because those are the most critical ones we need. So PP plot, QQ plots, those are just normal plots, which we can still see in other areas. And we use it when you are looking at distributions to know if a particular variable is following the normal distribution or not. So we use all these PP plots and QQ plots. Now, let me first go back to frequency. In when you are analyzing a particular information or you are given a work to analyze on, the first thing you are going to do as a good analyst is that you have to find the frequency of all the variables on that questionnaire. That is just for us to be able to see what is the properties, what is the characteristics, what's the information that this data is giving us. So whether the person might be interested in the influential aspect of it, but the first thing you have to do is to do the discrete statistics, the frequencies. The person, if he needs it or doesn't need it, just do it. You need it, that's the first line. So when you want to do that, just click on frequency as I've done now. Then this frequency I've done, if it's all the questions on this particular data I needed to do, it doesn't mean I have to pick them one and within it. I can, it's either you pick the ones you need, and if you need everything for frequency, you can highlight everything. There are two ways you can do that. It's either you click on one and press Ctrl A. It will highlight everything on it. But sometimes you might have some variables here that it is not, it's not part of what you want to do. So you may not do it like that. You might click on one and press your shift on your keyboard and use your down arrow key to be taking it downwards till you reach the stage you want to analyze. So let's assume I'm interested in just these four variables. I'll stop there. Then I'll use this arrow to bring it to the variable box. So once I do this and I click OK, it will give me information on my frequencies. If you look at it now, the windows with the output windows comes up. In this output windows, you can see the first table you are seeing is statistics. That is, statistics is just giving you, the first statistics table is giving you just the summary that, okay, what is the number of observations we have looked into? This is 30. How many missing do we have? It says 0. Now, this is where you're going to know whether in the variables you are working with, if probably there's anyone that has missing, If it's having a missing, then this one will not be up to 30. So you now be wondering, how did I have missing? So this is where you can cross-check. Sometimes if you want to be able to be sure whether our data is already in the normal form, we first of all run this particular frequency because it gives us where I'm having missing or not. Because sometimes there is a need not to be a missing in some questions, and you notice that there is missing there. So you can easily trace which of the areas do I have missing values and why and what happened. So if it's something that is needs adjustment, you can do it. Now, secondly, after it has done that for me, it goes to each of the variables one after the other to give me the frequency table. If you look at the first question now, that is question 1. Now, this question 1 also has given me the real name. But if you notice at my normal data level, where I have here, you notice that if I go to my variable view, at my label section, you notice that it is empty. That's the reason. And because it is empty, the SPSS will not want to give it empty. It will go back to the name you have assigned for that question. So, but if assuming I've put a name in this particular label, then it is the name I've put here that I'm going to be seeing. So please, those are the things you are going to be seeing when you are doing your own too. So I'm only trying to explain to you. So now, if you look at this particular table now, you can see that it's table for sex. Now I'll be looking at it. How many frequencies do I have for male? It is 21. How many frequencies do I have for female? It is 9. So you'll be seeing percentage to be 30%, 70%. So valid percent. So what does valid percentage means? Valid percentage is very useful. You can see that valid percentage and the percentage you have here is the same. Yes, it's the same. But in cases in which you have missing values, it will not be the same. So the missing value will also be getting some percentage. So it will tell us here how many missing I have for male, or how many missing I have in these sex variables. Then for me to be able to stick to the actual data that has the real information, then at that stage, I'll be quoting the valid percentage. Because if I quote the real percentage, and I'm not interested in reporting the missing observations, then if you add my percentage together, it will not be up to 100. But if you come to valid percent will gives you the accurate percentage, leaving out the missing observations. So that's what it does. So now let me just give an illustration to that. Let's assume that this section where we have gender, let's assume I just remove this and I remove this. Now if I run this particular information again, frequency, now let me assume I remove these 3, which I'm not talking about now. I only leave these 2. Then I click OK. It will bring the information down here for me. Now if you see at this statistic, because I have missing, instead of me having 30 observations here, it gives me 28. And then it now comes and says missing 2. So meaning that I have 30 respondents, but out of that 30, only 28 filled the information, while 2 doesn't. So now, if I come to the frequency table, you notice that at frequency, instead of me having male and female alone, it will give me male and female and put total for male and female, which is 28. Under it will now give me missing. At least the observation is missing. Then say 2. Look at the percentage itself. You see, for male, it says 26.7. For female, it says 26.7. For male, 66.7. Total everything is 93.3. We see it is not 100. Now it now comes down and says missing values is 6.7. Then when you add everything together, it gives us 100%. So now, if I'm reporting now, and I'm not interested in reporting missing values, because sometimes you see some lecturers in which they will tell you that you should remove all the missings. If you remove all the missings, I only limit your interpretations to the 26.7 and 66.7. When someone else look at that work, it will tell you that you have done rubbish because initially the percentage should be equal to 100. Yet it's equal to 100, but the missing you have removed and you are not giving account for, we also be having issues. So instead of that, instead of me quoting the percentage of the normal percentage, I'll come to valid percentage. So in the normal valid percentage, we only calculate based on the sex itself, male and female, excluding the missing value. So at the end of the day, I have 28.6 for female, I have 71.4 for male. So That is just the information. So if you want to interpret, there's nothing special in this. It's just that the way we interpret will be different from the way you interpret. There's no better interpretation. The only thing is that you just have to determine how you can put words together. Now, if I want to interpret this, I say, okay, from table, so maybe it is table 1, showing the distributions of gender on the case studies of Kiniko. At the end of the day, 78.6% of the respondents are female, while 71.4% of the respondents are male. This shows that, we never conclude that majority of the respondents that took part in this particular research or this particular survey are male respondents. So you can make your conclusion as any how you like it. But in as much as you have brought out the information, that is what matters a lot. So the interpretation determines how you can put words together, how you can compose English, how you can do that. But no matter what you want to do, ensure that the parameters you are stating is correct. That's all. So after that, you can look at the other variables also we have talked about. We see age group, so position in organizations, years of experience. You can see each one of them are having their frequencies, percentage, frequency. So when you are reporting this, most of the times people come to with, okay, let me bring demographic information to table 1. Let me take the other particular section of the questionnaire to be table 2. And sometimes some people will decide to, okay, I'll be picking my table one after the other, and be reporting it one after the other. It's your choice. And depends on what the person that you're working with wants. So that is how you can get frequency in terms of percentage and frequency. Let's assume I only just need, okay, before I leave that, let me go back to, okay, assume I don't even need the frequency, I only just need some descriptive information like mean, median. Instead of me going to frequency, I can come to descriptives. Descriptives, okay, let's say I want descriptive, I can highlight the 4 I need, then I put descriptives here. There's nothing else I will do, I just put okay. So if you look at descriptives now, what it will give me is that you can see descriptive is just only one single table. And you can see it lists out all the variables I've picked at the first column, and then it gives me the number, that is the total number of observations I've taken here, and then it gives me the minimum, the maximum, the mean, the standard deviation. That is all it will give you as descriptives. So if this is the only things you need in the question, so that's what you are going to pick. But as you need more information, instead of coming to descriptives, there's still another areas you can do that. You can combine all these things even in the frequency level. So instead of, I can also come back here and say, analyze, come to descriptive statistics, then pick frequency. As I've picked it like this, I can decide to add more to the information and have it like this. Now, instead of me clicking OK, which I did at the first section, I can come to statistics. When I pick statistics, it gives me another information. Now, I may decide to say, okay, in this particular information, I need the mean, I need the median, I need the mode. You can click anyone you want. I need the quartiles, I need the percentiles. At percentile, you can say which one percentile, is it 50 percentile, is it 25 percentile? It's your choice. So you pick the percentile you want. Then you can look at the dispersion too, variations. You can click, okay, I need standard deviation, I need variance, I need the range, I need the minimum, I need the maximum, I need the standard error mean, I need the kurtosis, I need the skewness. So you can decide. It's your choice. So instead of you going to descriptives and do that, no, descriptives will not give you all this information at once. But at the frequency level also, you can pick the statistics you want to come up with. So everything, though I only just click on this, does not mean that I need all this. So it depends on what you need. We determines which one to click. So I'm only just showing us how we can get those information when we are working on SPSS. So at the end of the day, I can click my continue. Now let's assume, instead of me going to draw charts separately, I want my chart. I can also as well do that at this level. Click on charts. In this chart, I have bar charts, I have pie charts, I have histogram. Let me use this opportunity to tell us something. When you are dealing with data that is categorical in nature, whether it is nominal or ordinal. Please, histogram is not the best chart for those informations. It's either you use bar charts or you use pie charts. We use histogram when you are dealing with continuous informations, like scaling informations. Like I want to find the age. But mind you, if you have sectioned your age to categories like, okay, 25 to 27, 28 to 30, no, you can't do that. I'm talking about age in which you have limited them to just pick or to just put whatever they want. Then, or maybe you put something that has to do with weights. Those ones you can use. So what I mean is that when you talk of categorical informations, sex, color, marital status, all those ones that are categorical, whether they are ranking or they are not ranking, don't plot histogram for those cases because they are categorical. Histogram is best used when you are working with continuous data. Please try to get that. Because histogram, we put their bars. The bars we sleep on each other. So that is when you now say, okay, I want to plot my curve. I want to see if it is number. So we use histogram mainly when you are dealing with continuous data. So because most of the time, so people just draw plots. They never know which type of plot fits in with the variables they are working with. So in this case now, most of the variables I've picked, they are categorical variables. So I can pick bar charts. If I click bar charts, you can as well as pick which of the bar charts do you want it to come up in frequency form or in percentage form. So I can say, okay, let me come with percentage. I don't need the frequency. I can click continue. So after that, then you can click OK. When you click OK, you always find your latest information at the end of the previous informations. So now, the information I just instruct the SPSS to do for me is what you are seeing here. You can see that all the variables I've picked are listed at the first row. Then, each of the information statistics I picked out were listed at the first column. You can see it will first give me the valid and the missing. Then, mean, standard error, median, mode, standard deviations, variance, kurtosis, skewness. All these kurtosis, skewness, we use them only when you are trying to look at normality distributions. Normality distribution. So that's what. So the closer they are to zero determines how normal they are. So minimum, maximum, percentile, 50 percentile, 25 percentile, 75%. So this is just the characteristic informations in terms of statistics of a thing. So you'll be able to be seeing what do I need to pick. So that's what this one has done for us. Likewise, also it will give us our frequency table. At the end of the day, you can see frequency table for each of the questions. Next, you are going to be seeing is the charts you have instructed the SPSS to plot for. So the first chart is for this gender, now male and female. Now you can edit charts too. If probably you want this color to not be the same, you want it to be a different color, you can do that as well. How do we do that? You bring out chart editor. Now, how do you bring out chart editor? You click on the chart itself. When you click on the chart, as I click now, you cannot double click on it. When you double click, something will come up, which is what? Another dialog box that is showing that plot. This is chart editor. Now, chart editor, I can do whatever I want to do. Like, for example, now, this particular Q1 is not the name. I want to put the actual name. What I will do is that I can click on that Q1 section. When you click on that Q1 section, you can see that something come up. Then I can bring my cursor to the side of the something. Then I can highlight and then I can change the name to whatever I like. I can say distribution. Okay, gender distribution. I can say gender distribution. So once I do that, I can go to the next one. Then secondly is that if I want to bring in, I want the actual percentage to be on this bar. Okay, first of all, let me say I want to change the color. I don't want the color to be the same. what I will do is that I'll click on the bar itself. When I click on the bar itself, the two bars were highlighted. If you look at it very well. So if I'm looking at changing one of them, as they are highlighted, I will click again the one I want to change. So you can see that I'm putting my cursor on the bigger one, on the highest one, which is the male. If that is the one I want to change the color, I've clicked on it on the first case, it highlighted the two. So I'll click on it the second time. When I click on it the second time, you can see that it's only the male that's being highlighted, the female section is not highlighted. Then come to this where you have this symbol. If you look at my cursor very well, you see this place. Use your click on it to bring this arrow down. You can see under other colors. Then I can decide to pick any of the color I like. Click on it. When I click on it, it's changed. So that's one. Another thing also you want to do is that let's say I want to put the actual percentage of each one of them on the bar. Then I'll come to this where you have options. Okay. Come to where you have these elements. When you come to this element, you see data label mode, this sign. Click on it. When you click on it, come to the bar. Click on it again to give it percentage. Come to the second one, click on it to give percentage. By the time you are done with that, you come to the element again, you click on it, that means you removed it. Then I can close this. So now let's assume there's nothing else I want to do. Let's assume there's nothing else I want to do. Then I can now, so okay, this main section 2, where I have Q1, I can delete this and says gender. So wherever I want to change, just click on it. Whatever you want to change, just click on it, you will change it easily. Then when I'm done with the editing, I'll close this chart editor. You can see where I put my cursor. I'm trying to close it. When I close it, it goes back to the normal data output. If you look at it, what I've done as the data editor will be automatically reflecting on the normal output window, which we are seeing now. So if you want to work on this, now first of all, when I'm talking, there's a way we do this. This is my result. I can click on it, this frequency table, you right click. When you right click, you see cut, copy as. So click on copy. When you click on copy, then come to your Microsoft Office. As I've done now, I'm trying to open a new page. Then I can click paste by clicking Ctrl F. So what you have copied in the SPSS will come here. Then let's assume the charts I've drawn too. You just click on it like this, right click, click copy, then come to where you have your Microsoft Office, then paste. So you can as well on your data, on your SPSS, instead of right clicking, just click on it. If you click Ctrl C, it will copy. Then come to your documents, which is Microsoft Office. Then take this one downwards. Then click Ctrl V again. You can copy. So it's of the same mode. Is either you use the shortcut or you use the normal clicking. And so this is how we bring our results to the Word document. You can also export it, but if you want to do it one after the other, this is how we do it. So till you finish your information. So that is how we work on frequency. So then we also want to talk about, we have talked about descriptives. We have talked about, okay, let me say explore. What is explore? When I click explore, I can bring in my information. Like let's assume dependent list is just my gender. I'm not interested in doing anything again. I can click OK. Then you can as well click on statistics to see what you want to do. If you want to know the outliers, if you want to know the percentile, you can do that, but there's no need. So the plots too, you can decide to pick any of the plots, stem and leaf, histogram, and the likes. Papa. So that's that. So then at display here, I can pick both, that is to give you both statistics and plots. So if I click both to give me the information, then I click OK. So you look at the difference now. What will happen in this exploit is that, look at it very well. You see that it gives you the descriptions for for Q1, which is the gender. Now look at it very well. It gives us the mean. What's the mean of the gender? It gives us the mean. It gives us the 95% confidence interval. It gives me the percentage. It gives me medians and the likes. So that's what that one does. Then it's now be giving you the stem and leaf. This is because we have only one information. So let's assume I have multiple informations. I want to check. Like for example, somebody that does with chemicals, or maybe are trying to test 3 variables. You are trying to test 3 or 4 variables to know whether there's a significant difference in them. So this is how we do it. You can subject them to. I'll click on the 3. I'll subject them to this particular information statistics, and then to run out all these informations for me. Then I'll not be able to compare that. What is the mean at this level? What is the mean at this level? What is the mean at this level? So that is. I'm only just trying to show us how to do it, where to see it. So that is the main thing. So for those of us that are in those areas, you understand what I'm saying. So also the crosstabs. Let me suspend that one. I'm still coming to that later. Okay. No, let me do it once and for all. Crosstabs. Most of the times we use crosstabs when we are dealing with chi-square. When do we use chi-square? That's the first question you have to ask ourselves. Chi-square is one of the statistics that we use to compare relationship between variables. Now, variables can be compared in 2 folds. Let me give us 3 things now. These sections is not about just clicking alone, it's about understanding it. So please, if you have the time to write, please write. There are 3 things I want to give us now that are very crucial whenever we are dealing with analysis. Now, we have 3, let me say we have 3 variables, we have 3 statistics that we use in when we are working with relationships. But I will not put it that way. Let's assume you have a variable that is categorical, and you have another variable that is continuous, and you want to test the relationship. The statistic we do use in those cases is t-test. When you are doing t-test, because t-test, the one that is categorical will be serving as your independent, or whereby your continuous variable is serving as your dependent. We are still going to get to that. But when you are looking at relationship of variables that the 2 of them are categorical, when you're looking for a relationship between variables, you are not that we identify whether they are categorical. It is based on the variables that you're going to know whether they are categorical. If you are looking for a relationship, associations between variables that are categorical, the statistic you are going to use is chi-square. So sometimes you see some people analyzing. You see the variables they are working with. Maybe the first variable is gender. The second variable is educational status. And they will be telling you that they want to use regression. How does regression work in that end? No. When you talk of relationship does not mean when you talk of relationship, it must be regression, it must be correlation. No. You have to be able to be assured, you have to be sure the kind of data, the structure of that data you want to use. So that is what will form the basis of the analysis to use. So if I'm looking at relationship between gender and educational status, I want to see whether you're a male or female determines your educational status. Male and female is a gender, they are categorical. Educational status, primary, secondary, tertiary institution, they are categorical. In those cases, you are going to use chi-square. So that's why you're going to be testing whether there's a single relationship between them. There's not. So it is chi-square. So, but if you are looking at variables that are continuous in nature, 2 of them are continuous in nature, then you are going to be talking about correlation. You are going to be talking about regression. But there are 2 differences between correlation and regression. Correlation and regression measures relationship, but mostly regression looks at the impact, the influence of independent variables on dependent variables. Take for example, I want to look at influence of agricultural sector, manufacturing sector, Retail and trade section sector services sector on their performance on the GDP of Nigeria. Those sectors are independent because those sectors are the ones that contribute to what our GDP will comes up with. So our GDP is depending on those variables. So in those cases, when you're working on those kind of variables, then you are going to be looking at regression, because you are going to be saying that, okay, this is the percentage at which this sector is influencing this particular variable. When you're working with those kind of things, you are going to be using regression. But regression is also having some other forms. So when you are looking at one independent variables, we talked about simple linear regressions. But when you are looking at independent variables that are more than 1, 2, 3, on dependent, so that's when we talk about multiple regressions. Now, but there are some cases too, so that it will not look like maybe you go outside now and say, no, the person that taught us said when you're looking at variables that are continuous in nature, it must be regression. But if you have a cases in which you have a variable that is continuous and you have some that are not continuous, that are categorical, and then testing their relationship too. No, they didn't say that to us. They said it's not, it's chi-squared. No, there are some cases because we have something called logistic regressions. Logistic regression, we have binary, we have the multinomial logistic regression. But sometimes you have some cases in which your dependent variables will be having categorical form. Like for example, you want to test relationship between smokers on some factors that constitute to their smoking level. So you now be testing that, okay, if you smoke, 1, if you don't smoke, 0. So you have something of those variables. Now for that variables that constitute to smoking, you have them. And looking at the relationship, in those cases, we can use logistic regression, which is binary logistic, but that is not for this training class. That is advanced level. I'm only just telling us that we have cases in which sometimes you can also have variables that are categorical in nature that will still use regression. So that is where logistic regression comes in. But for this class, for these sections, we are not going to that section. We are only going to be limited ourselves to just regressions, simple, and if you want to know more about that, you can further your learnings. Now, for correlation, there's a difference between correlation and regression. That's what I want to explain. I've explained regression. When you are looking at the strengths, we are looking at the strength or the degree of relationship of variables that are continuous in nature. That is when we use correlation. And correlation ranges from -1 to +1. The closer they have to 1 determines how strong their correlation is. All these things I'm saying, don't look at it as if it's a story talk. It is what you need in anything you want to do in analysis, because those are the things that will form your basis of interpretation. I want to just explain this, that is just a classroom form. So that is things you need. So try to note them down or try to understand them very well. So when you are working with correlation, the closer they are to 1 determines their level of correlation. The closer they are to 0 determines their weakness, or their 0, and it also determines how weak they are to how weak the relationship is. So if it is positive, that means that they have a positive relationship. So as one is increasing, the other also will be increasing. As fuel price is increasing, the market price, foodstuffs are increasing. That is 1. I'm not saying that, I'm only just giving an illustration. If your correlation level is minus, that means that as one is increasing, the other is decreasing. Meaning that as petrol price is increasing, the rate at which you eat at home, the level of eating is also reducing. 100, 001, 010, 101. Illustration. Or as your expenditure, as your income is increasing, what happens to your expenditure? Increase or decrease? I don't know. But I'm only just trying to tell you the relationship when it comes to negativity or positivity of it. So the level at which you are going to be having, so when you are looking at the degree of the relationship, that is where the correlation is coming in. But most of the times when you are looking at normal relationship, when you calculate the regression, correlation also will come, because correlation will have to tell you their degree of relationship. So if there is no relationship in that variables, the regression also will not be meaningful, because there must be a relationship before regression can tell you what is the level of their influence. That if this is having this percentage, then that means that a unit increase in that will give you this level of percentage. So that is what regression is saying. So now for chi-square, as I was explaining, let me quickly digest this descriptive statistics level. I'll come to crosstabs. I'll click crosstabs. Then I'll pick the variables which I want to look at their relationship. Now I want to look at relationship in terms of the gender, the age group. I can put it at the row. Then I want to look at the highest level of education. Then I'll put at the columns. Now after I've done that, then I'll click on the exact. So when you click on the exact, there's nothing you want to do here. Just leave the information as it is. Then I'll click on the statistics. At the statistics level, you are going to see chi-square. You are going to see correlation. So initially at this level, I'm only interested in the chi-square. I'll click on this chi-square. So then I click OK. So the cells. So observed frequency is just the normal frequency. If in the classroom level, for you to calculate chi-square at the normal level in the classroom, before you can calculate the chi-square, it will be summation of the expected value of the observed frequency minus the expected frequency, all squared divided by the expected frequency. Now, in the classroom, you have to get your expected frequency before you can calculate your chi-square, but we are not in the classroom. So in this case now, I may decide not to put the expected because I don't need it. So now, I'll leave it as if I observe frequency. Then you can now sort your percentage. You want to sort the percentage based on the row wise. If you are interested in the relationship in terms of the age, then it will be row wise. If you are interested in terms of the highest level of education, it will be column wise. So whatever you want to do, will determine the percentage you are going to pick. So I click continue. Then I can now click. So I can decide to have a plot to see what is the interrelationship. Then you can click on the cluster bar charts. So it is not until when you get to the graphs before you can plot graphs on SPSS. Even at the operational level, you can still indicate the graphs you want. But if you are interested in only graphs, you don't need all these ones. You can always go to graph section and plot whatever you want to plot. So I'll click this OK. Then the information will come in. So you can see how the question will come. You first of all see the normal cross tabs information, which you have there. So in this case, we are having age group cross tabbing, the highest level of education. So what will be the hypothesis for this? The hypothesis will be that there is a significant relationship. Okay, there is no significant relationship between the age group and the highest level of education of the participant. While the alternative hypothesis will be talking about there is relationship. So if alternative hypothesis is saying there is no, the other will be saying there is. Because one, you must identify the hypothesis, because that's what will form your conclusion. Now at this level now, I can now say, okay, cross tabs, when the age is 18 to 25, what is the bachelor level of degree? Said it is 12. What is the doctorate 0? So this one is just normal frequency level. I don't need it. You might interpret that as your level if you have the time. But what I'm interested in is this chi-square table. Now you can see Pearson chi-square, likelihood ratios, linear by linear. The one we need at this table is the Pearson chi-square, because that's the chi-square we use for parametrics. Now, look at where we have asymptotic sync. Asymptotic sync is equivalent to p-value. Because if you run this particular test on SPSS, most of the time it will be giving you asymptotic or sync. Asymptotic or sync. Asymptotic or sync. Whatever the case you may be, you'll see one of the two. But in some other softwares, like HAR or thereabout, you are going to be saying something like p-value. And most of the times we interpret with p-value. So asymptotic sync or sync is equivalent to p-value. Please have that at the back of our mind. Now, the condition on interpretation in statistics is that when your p-value is less than 0.05, when your p-value, please take that information. When your p-value is less than 0.05, that means you are going to be rejecting H0. And by the time you reject H0, you are accepting H1. That is in terms of acceptance of H0, H1. In terms of significance, the moment your p-value is less than 0.05, that means there's significance. There's significance in the test. So that means the variable, the result is significant. But if it is greater than 0.05, that means there's no significance. That means the value is not significant. So I've given you two ways now at which you can use p-values. Firstly is that p-value in terms of hypothesis testing, if it is less than 0.05, you are going to reject H0, which is the non-hypothesis, which is the researcher claim. Non-hypothesis. Now, another hypothesis is the normal test claim. Researcher claim is H1, which is the alternative hypothesis. So if your p-value is less than 0.05, you are going to reject H0. If your p-value is greater than 0.05, you are going to accept H0. I don't know whether you understand. If your p-value is less than 0.05, that is 5% level of significance, which is the universal level. But if you are dealing with something that has to do with the medical tests, they always subject them to 0.01. So how do you know that? The values you are having will determine whether it is less than 0.01 or less than 0.05. But for something that is not medical or thereabouts, mostly people are in engineering class. Most of them, they always take their own signal level to 10%, which is 90 confidence interval. So we have three of them: 90%, 95%, and 99%. So, but the universal one, which is the benchmark, the most common one, is the 95% confidence interval. Meaning that you are 95% sure, 5% is for other contingencies that might not be in the consideration of your research. So look at it at p-value now. You can see that my p-value is less than, it says that the value of my p-value is less than 0.001. 0.001 is less than 0.05. So in this regards, I would say that what? There is significant relationship between the age group and highest level of education. Because my H1, my H0 is that there is no significance. And from this case now, once my H0 is there's no significance, and I've said that once my p-value is less than 0.05, that means I'm going to reject H0. I'm going to accept H1. So my H1 is that there is significant relationship between age group and highest level of education. So with this result now, my p-value is less than 0.05. So I'll be concluding that from this result, the basic chi-square is 27.857, which is with p-value of less than 0.001. This implies that there is a significant relationship between the age group of participants and the highest level of education. That's my conclusion. That is my information towards this result. So that's what we look at when we are interpreting information. But if the chi-square, if the p-value is greater or equal to 0.05, that means I will be saying that what? There is no significant relationship. And that is that. So that is on the chi-square level. So I've been talking for the past 45 minutes and thereabouts. At this section, before I rush to another level on another section, if you have any information or any question, please ask. If you understand, let me know. If you don't understand, let me know, so that I will not just be talking. Please, can you hear me? Do you understand what we have been saying all this while?
Yes, we can hear. I can hear you.
All right. So now, if you hear me, do we understand some of the things we have explained to us and we have shown us?
I can understand.
Okay, that's fine. Yeah, so I think we can move on because someone has confirmed that. Yeah, so the next I want to show us is, okay, before I go to the inferential statistics level, let me quickly go to how do we plot. You can come to the graph. There are two ways at which you can plot. It's either you use the chart builder or you use the legacy dialogues. If you want to use the legacy dialogues, when you come here, you can pick on each one of them you want to use. If I want to plot the bar chart, as I clicked on it, I'll click. If it is a simple bar chart, I'll click on it. If it's a cluster bar chart, if it's a stacked bar chart. So how do you know which one of them are you going to use? You can see the pictures they put beside them indicates the nature of the bar chart you want to draw. Let's assume the bar chart you want to draw is like you are comparing. That's where you use clusters. Simple bar chart is just normal bar chart. If I click on simple bar chart, then you want to summarize your cases by group or by separate variables. Well, most of the time you want to do that by group cases. Then you click on define. If you click on define, I can bring in my normal variable here, then I'll put it at the category X. So do you want to plot them in cases of n cases? Do you want to plot them in percentage of cases? Cum number of cases, cum percentage. In terms of the mean, you are going to decide. If you are interested in n cases is just like you are plotting in terms of the frequency. If you click on the percentage, that means you are plotting in terms of percentage. Then, if you want to put your title, I can click and put my title to be say, okay, distribution. Okay, let me say gender distribution. Then I'll click on continue. So I can click my OK. So it will give me my bar chart, which I have here. So what I've done in the other case, this is what we have now. So it's either you plot directly or you can plot at the normal frequency level. So that is that. So how do we use other sections? Let's assume I want to use chart builder. I don't want to use negative dialogues. I can put chart builder. When I click chart builder, the difference is that it will give me a dialog box. Then I can now pick which of the chart I want to use. If it is still my bar chart I want to use, or if it is my line chart I want to use. So what I need to do is just that click on the picture, then you are going to drag. How do we drag? You have clicked the picture you want to use. Let me use the bar chart I've been using so that it's not confused. Then I need this. I'll click on it. I'll click there. Then press your mouse at the left hand side of your keyboard. Then use your finger to just take it up. If you're using a mouse, left click, down, press down, then shift the arrow up. Then you drop it. When you drop, it gives you the structure at this level. Then the variables you want to plot, they are bar charts. You click on it, then you bring it, you drag it to where you have your x-axis. Your y-axis will give you the normal frequency count, so you don't need to put anything there. So if you want to do any other informations, you can do them. If you want to put your title, you can click on title, then you can click on this. Then I can click on my OK. You can change your statistics to percentage if that is what you want, as I'm done here. Then I can click my OK. So when I click OK, you are going to see the different informations. So I can decide to edit this. Double click on the chart to give you the dialog box. Then if you want your title, look at this symbol here that I have here. Is insert title. You can click on insert title, then you can highlight this one and just says age group distribution. whatever you want to put the name, whatever name you want to put, you can put it. I can always delete this. I don't need this now. I can change their color. Once I click the bar at the first instance, it will give me, it will alert everything. So if I click on this bar again, it will only show this bar. It will only alert this bar. Then I can change their color as I like. I'll click on the other bar to change. It will give me that same bar, and then I can change the color. Then the last one, I'll click on it too. Then I can change the color. So once I'm done, if I'm still interested in doing another thing, I'll continue. If I don't, then I'll click close. Then it will close. Then you see the better information. Then you can always take it to your Word. So that is how we use graph to plot. So you have different type of graphs. It's not only bar charts. We have line graph, we have area graph, we have pie charts, we have scatter plots, we have histogram. So let's say I want to put my histogram, I can put it here. Then I can drag, as I've dragged this one, it comes up. Then I can now pick which of the histogram. This age is continuous. I can pick it. I can bring it down here. Now, assuming I want to show my normal curve, I can come here and click the normal curve, display the normal curve. It is, you see, it has put it there even before I finished it. Then I can click my OK. If I click my OK, it will give me the histogram. You can see the histogram. Then it will give me the curve as it is. Is it normal? It will let me know. Is it not normal? It will let me know. So this is how histograms work. So this is how you can use your graphs. And is it that you use this legacy dialog box, or you use this chart reader? But most of the times, just reader, because it's like you are designing, it's an architectural work. You can click, drag it, click on what you need, you drag it here. Once you drag it here, you can always put your information, which one do you want. If it is still the age I want to put, I'll click on this age, I'll drag it here. So drag it and ensure that it works with where you want to put it. So I'm putting age is not taking it. Doesn't mean that age is not responsible for this. Let me use this. Then I put it here to take it. Then I will indicate other information I want to put. So age, then range, what again? So the moment the information you want to do is complete, this OK will complete. So that means the information is not complete. So we cannot use this for this particular information. So that's how we draw charts with these informations, as the case may be. So you can always do whatever you want. Determines what you want to do. So that's it. So now let me now go to the next section, which is compare means. Where do I find my t-test? You are going to see your t-test as the area which we have compare means. Compare means. Now we have one sample t-test. That is when you are trying to look at the information on one population. Take for example, I'm trying to look at gender or age. That is there a significant difference in the age of the sex? So the test I'm doing is on age, but on what? On the sex. That's one sample. But if, okay, one sample, let me say one sample is like when the population is 1. But if the population is 2, like for example, age now, I'm trying to test that age, the mean age of the respondent is 20. So then I will now be using one sample. But if it is 2 samples, that means it must be 2 populations. So now let me assume I click on this particular one sample now. This is what I'll have. Then I'll now be looking at the test variable. My test variable is the age, because this age is continuous. Then I have to have test value. The test value is that, as a researcher, I said the average age of students of UI is 20. That is my my claim. Then I'll not be testing. Is it true? Is it 20? It's not 20. Is it 20? It's not 20. So the average age is 20. It's not 20. So then I'll put 20 here. That's my test value. Then I'll click OK. So it will run the information for me and give me my results. So the test value is 20. Then my t-test is 3.893. So my significance, which is equivalent to p-value, is giving me values less than 0.01, which is less than 0.05. So then I have other informations like this. So if I want to report this information now, I'll be interested in the sig, which is the p-value. Because SPSS always have sig as its own cases. When other software you have p-value. So, but if you have sig, it's equivalent to p-value. This one is saying that what? The mean age is 20. The mean age is not 20. So that is the test one. So now with this now, if it is significance, then there's significance if it is less than 0.5. So the result, the t-test value is significant at 5%, which concluded that what? The mean age of US student is 20. The hypothesis, the end hypothesis says it's not. The alternative hypothesis is saying is 20, which is the mean age. So, and it is significant. So that is what we use in interpreting in the result. But if it is a two population, let's assume I want to take gender. Gender has male and female. Then I will not be picking. So if I want to do that, I will not pick one sample again. I will be picking independent sample t-test. That is for two samples. Independent sample t-test. So when I click independent sample t-test now, it will give me this dialog box. My text variable is what? My text variable is the age. Is the age I'm texting on what? I'm testing it on the gender. So now, after that, I'll now pick the other variables, which is gender. Then I'll pick that grouping variable. Then I'll now click on define group. That define group is where I'm going to specify what is the code I've used for my gender. What is the code for male? I've used 1 and 2. So now in this case now, I'll say group 1 is 1, group 2 is 2. But if you have used another coding number, is the coding number you have used, you are going to put here. Then I'll click continue. Then I can click OK. When I click OK, it will give me two sample t-tests. And this two sample t-tests, it will give me what is the information of the female is 8. Information of male is 20. Then it depends sample t-test. It will now be giving me 11 tests of equity of variance. Now this one is talking about this first test you are seeing is for you to pick whether you have equal variance assumed, you have equal variance not assumed. So if this particular sig is less than 0.05, that means equal variance is assumed. So but if it is greater than 0.05, that means equal variance not assumed. So now with this now, I'll be picking equal variance assumed. Then it is this first row I'll be putting my intention on, which is that my t-test is minus 1.465. Then my sig is 0.155, meaning that it is what? It is greater than 0.05. And when it is greater than 0.05, I'm going to accept H naught, whereby I'm going to get H1. And in this case, for t-test, my H naught is saying that there is no significant difference in the age of male and female participants, whereby my H1 will be saying that there is a significant difference. So with this interpretation now, since my p-value is greater than 0.05, I'll be concluding that what? There is no significant difference in the age of gender of male and female, because the p-value is greater than 0. But yeah, assuming the p-value is less than 0.05, I'll be concluding that what? There is a significant difference in the age of what? Of male and female. But as for this result, the conclusion is that there is no significant difference. There is no significant difference in the age of male and female participants of this study. So that is how we make our conclusion. And that is what we look at in making our conclusion. Whether you are working with this software, you are working with another softwares, whatever you want to do, what you needed to do to know is just to identify your p-value. Identify it, look at it, is it greater than 0.05? Is it less than 0.05? So if it's greater than 0.05, what is your hypothesis? State your hypothesis, get your hypothesis right, and make your conclusion. That's what you need on this section. And that is how we do what we call the T-sample test. The other test I want to show us is the paired sample t-test. For those of us that do experiments, that has to do with experiments, you are conducting experiment in rats, and maybe a vaccine. You're not doing it, you are taking a reading before the injection of the vaccine. Now you're not taking the reading after the injection of the vaccine. So you are taking maybe the weights or thereabout, I don't know. You might be taking anything. So that is where PIT test comes in. So PIT test does not, because the reason is that it's a dependent test. Because the two results might be different, but you are taking it on a particular animal. So which is just one single population. So it's not independent sample t-test. It's a dependent sample t-test, which has two observations. So when you have that, people that do information in which that, if you are taking two readings from one particular information, one particular set, or one particular organisms, or one particular animal, but you are taking two readings out of that particular animal, that is where you have peer test. So, or maybe you are trying to test a product, you are not subjecting it to some people to use it. What did they see before using it? Oh, what are they? And after they have used it, what is the outcome? So when you're taking such results, such information, we use paired t-test. And how do we run paired t-test? So that is why I'm going to carry us back a little bit to the data I shared with us recently. So now all you're going to do for me is that come to your file, because the data is in Excel. I'll come to my file, I'll click on open, I'll click on my data, then I'll come to this file type, I'll change it to Excel. So if you have it on your own end, you also can do that. Then I'll locate where I put the file. In my own case here, I put the file at downloads. Downloads. Then at downloads, I have different information here. Sorry. So I'll try to look at. So I think I stored the information with paired t-test. Let me check my download so I should be sure. Yeah, paired t-test. So I saved the information as paired t-test. So the information here is paired t-test, which is this. I'll click on open. When I click on open, I'll wait for the dialog box to come in. So as the dialog box comes in, then I've indicated that the first variable is name of the row, the data. Then I will click OK. So when I click OK, if I've seen the data very well from the Excel sheets, this is how it looks like. So there's a particular treatment that was done before. And then after the treatment, they take some readings. Then they want to know whether there's any significant difference. So then what I will do here is that I'll come to analyze, then I'll come to compare means, then I'll click on paired sample t-test. So I'll pick the two at once, then I'll bring it in. So you can see variable 1 before the treatment, variable 2 after treatment. Then at the end of the day, I'll click my OK. So now this result will be displayed below here. So you can see t-test, you can see paired sample t-test to give us statistics. What is the mean before the treatment? It gives us what is the mean after treatment, and it gives us the other information like standard deviation and mean. Then give us the pH sample correlation. Like, is there any correlation between the two information, between the two readings? He said yes. If you look at this correlation, I said the correlation is 0.898. So it's very close one. So that means there is a strong positive correlation between the readings of the treatments, which is significant. So meaning that there's a significant relationship. There's a significant strong relationship between the treatments, which is before and after. So then I have to check statistically that is there a significant relationship, or is there a significant difference, or there's no significant difference. So with this now, I will check. My mean is this, my standard deviation is this, then I'll come to where I have my t-test, which is minus 5.168, and my sig, which is equal to my p-value, is less than 0.5. So this means says that's what? There is a significant difference. There's a significant difference in the means of the treatments. There's a significant difference in the means of. So assuming the value is not greater than 0.05, I will be concluding that there is no significant difference in the means of the treatments. So with this, there's a significant difference in the means of the treatment. So now the other thing will now be giving us the paired sample effect size. That's why you are going to be having Cohen's and the Hedges correction. So, but the most important thing I need in this particular case is the p-value to know whether, because initially what your test is doing is that you want to know whether the test you are conducting, whether there's a significant difference in the means of the variables you are testing. If there is, you have to let us know. If there is none, then you have to let us know. So, but what determines what you are going to know, or what you are going to use to determine whether there is a significant difference or there is no significant difference is your p-value. So if it is less than 0.05, that means there is what? Significant difference in the means of the treatment. But if there is no, if the p-value is greater than 0.5 or equal to 0.05, that means there is no significant difference. So that is on the p-value and the PAT test. The last but not the least is has to do with correlations and regressions. Correlation and regression. So if you are looking at the relationship between variables, now this also goes back to the first data I shared with us, because I try to look at those data so that the information I will be given will be correlating with the data that relates to some of those things. So let me take the other data I shared with us. I'll click on open, I'll click on my data, then I will click on the Excel type, because that is information. Then I will look at the file. I think the file is on my desktop. I will look at my desktop. So as I'm doing my own, you can also locate where you put yours. Then I think I put it at this file. Then I will, I think it's not here. It's not here. Okay, let me change this one. Okay, let me check my. Okay, I think I remember where I put it. So I think it's on desktop too, but I have on the folder that I named. So you have to be able to know where that folder you are looking for the data is. So I think working journals published. So I'll put it here. I just see it. Okay, don't let me waste our time. Let me try to download it back from Mr. Mayowa's page. So CSV. Okay. So back to the page. Okay. So let me go back to my downloads. Then at my downloads, let me change this to CSV. I think CSV, yes, this is crude price productions. Then I click OK. Then I'll wait for my dialog box. So the moment you know what you want to do and you know where your file is, you always get it easily. So Yeah, I think I have some information here that okay, next, and I will click next because of the nature of the data. So this one is different, and then I'll click next. So invalid name for this particular question. So invalid name. Okay, let me put the name here, and the name should be a variable name. So okay, it takes. Then I finish this. So this is the information we have here now. The information is that we have a data that is having year, months, crude oil price, productions, crude oil exports. Now, I may be interested in looking at what is the interrelationship between what is the influence of exports and production on crude oil price. So now, in this case, that's where the regression comes in. So I'll click on regression, I analyze, then I'll come to regression, then I'll click on linear. Because we have different set of functions here. So what you want to do is linear. Now, if it is linear, I will now be indicating what's my dependent variable. My dependent variable is my crude oil price. I'll put my crude oil price here. Then, if it is only one particular independent variable so I'm looking at, then I put it here. That is when it makes it simple. But if it is more than one, once I click more than one, that is when it makes multiple. So it doesn't mean that there's a section you're going to do multiple alone. There's a section you're going to put. No, the number of variables you put here at the independent list will determine whether it's simple or multiple. Then after that, I can click my OK. So I think there's no information you want to do there. So with this now, you'll now be having information that has to do with, okay, model summary. At your model summary, you have your R. This your R is referred to as correlation coefficients. This your R squared determines the relationship of the model, the relation of the models that is influencing your dependent variables. The percentage at which is so the adjusted variables. This one is also working with relation with R squared, but this one is just talking about the exact one without having another influence based on other variables. Then this one is talking about your ANOVA. This ANOVA is talking about how fitted the model you are going to be fitting for this regression will be. Then this coefficient is talking about the influence of your variables. How influence are they to the crude oil price? Now, with these ones now, let me just use this sample to explain. If this your ANOVA, if it your this your SIG is greater than 0.05, that means the model is not a fitted model. So for your model to be a fitted model, this your SIG must be less than 0.05. And for coefficients, your dependent variable, your constant is your model, is part of your model, but the coefficient is the variables you are looking at. Like for example, here now the coefficient is the crude oil exports. So you are going to be looking at your coefficient. Your coefficient level here is 6.759, whereby your SIG, which is what you are going to be determining your interpretation, must be less than 0.05. But with this one now, it's not less than, it's greater than 0.5. So that means that this one is saying that what? The coefficient level, the coefficient of crude oil export is 6.759 with p-value of 0.103. This implies that what? There is no significant. That means that what? That means that a unit increase in okay, that means that there is no significant coefficient level with there is no significant coefficient relationship with crude oil export with your crude oil price based on this information. Does not mean there is no. But let's assume that this particular value is significant. Now I will now be reporting that okay, at a unit increase in crude oil export, we significantly increase the crude oil price by, so you now look at the coefficient level here. this one is 6.75. So I'll now be saying that it will increase by 675% increase. So now you now also have to determine whether this value is positive or negative. If it is positive, that means it's going to be having that percentage level increase in the dependent variable. But if it's having a negative value, that means it's going to be having a negative increase on the dependent variable. So what we always use this one to do is that we want to know the level of influence it's having on dependent variable. So, but for us to know the level of influence, these particular variables, each of the coefficients must be significant. If they are not significant, then you are going to silent on it. You don't have much information about it. But the moment they are significant, you can talk on it. So that is what we do. So like this production level now, though this one does not have any value, so we cannot do much interpretation on it. So that's why it puts it as excluded variable. So meaning that there is likely multicollinearity problems between these data. So, but that one is another level. So it's not for this class. So because most of us here are not in the statistics class. So and taking us far beyond what we can comprehend, we just disturbed the whole stories. So, but those are things you need to do. So how do we do it? That's what we have done. Let's assume we also want to look at the correlation, because when you are looking at correlation and regression, you also look at correlations too. So for correlation, I'll be picking bivariates. So I'll now pick these three to see what relationship is existing between them, maybe the level of their relationship. So if there's relationship between them, that means regression also will be good. But if there's none, then it's not good. But if I look at it very well now, Pearson correlation between crude oil will always be 1. So you don't correlate a variable that are the same. So if I correlate crude oil against production, it says it has a correlation level of 0.110. So that means it has a weak correlation. Then if you look at correlation of crude oil between crude oil exports, the crude oil price between crude oil export is also saying 0.110. So you might have other data that you can use. If you go to CBN, you see different data you can use for that. But I'm only just giving us illustrations on if you want to do it, how do you look at it? So now, if you are looking at this now, the correlation level will always be between -1 and 1. So the closer they are to 1 determines how correlated they are or their level of correlations. But with this one now, you can see that it is closer to 0. So that means it has a weak correlation. It has a weak relationship as this data is concerned. So we are only reporting, but based on the results of what we are seeing, does not mean that is what is happening. So, and if you look at others to productions, so productions under crude oil, we give you what you already have. Production under production, we still give you 1. So you don't correlate information that are the same together. You correlate with other variables. So if you look at that of production and exports, it's giving us a perfect 1. So that means there's a perfect relationship between those between the production and then the export. So meaning that if the production is high, then export also will be high. If the production is low, that means export also will be low. So that's what the meaning of this is saying. So, and that is on that. So that's just most of the things we need to know as this training class is concerned, and what I also want to share. We still have a lot of things we can still learn from this particular software, but based on this class, this is some of the things we will be introducing to ourselves. So if you have any questions as regards to what we have taught ourselves today, please let's come up with it. We cannot know it in a day. But the most important thing is just that get the knowledge, understand what they have said, then implement it and also practice with different data. You can always get data from any sources you like, and then for you to know it better, always ask questions. Always ask questions. So don't say because the class ends today, that is the end. If you have questions on anything you are doing or you need some guidelines, always communicate with Mr. Maiwa. He's going to get across to us, or even you can collect our contact directly. We can always explain to you, because the most important thing is for you to get it and also understand better. So not to put too much on our head. So I will be wrapping up the class at this section. And
All right.
for us to learn further, I will go to share a document with Mr. Mayowa, maybe tonight,
All right, sir.
which is a
Okay,
textbook.
sir.
That textbook is very, very
Oh,
unsafe. Like, I should not have released it. It's my personal textbook that I do use. But it's a step-by-step, self-explanatory. Teach yourself all these software SPSS of it. It will give you line by line
wow.
how you can do
Yeah.
things. So even the ones you have not explained there. So I will share with Mr. Mayowa at the end of this class for you to learn further. And if you have any questions, you can ask. So thank you. So if you have this question,
Thank you so much. Wow. We really appreciate. That is one of the best gifts we've received from this training session. We are so grateful, sir. We really appreciate you so much. So we right about now, I'll just hand over to Deacon. Deacon, sir, are you there, sir?
Yes.
Yes, sir. All right, sir. Yeah, the floor, sir.
Good evening, all.
Good evening,
Yes,
sir.
I want to use this moment on behalf of our Father in the Lord, Reverend Segun Akande, to appreciate our facilitators, Mr. Afis and Mr. Sanusi.
Yes.
Thank you for releasing your iron because they said iron sharpen iron. You have sharpened our knowledge,
Yes, sir.
and I believe, just like that theory of Lamarck, that's
Mm.
law of use and unuse. I want to encourage all the participants that we should ensure that we make use of all what we have learned on this platform, because as
Yes.
we continue to use it, we will keep on to develop our knowledge. But once we abandon it, it may not be easy to catch up. God will help us. Let's just put all what we have learned into practice. We have the software, we have the Excel, and the other one. Please, let's put them into practice. And to our facilitators, we pray for you because we know the value of what you have contributed to our life based on this program. God, that is the rewarder of righteousness, that is the rewarder of all good work, will reward you, and He will bless and satisfy all your longing in the mighty name
Amen.
of Jesus. Just
Amen.
as it was mentioned, if we have any questions, please let's relate with our brother Bomayowa. He will know how to reach them. Then, if possible, we know ourselves that we all the people that are active on this platform. Please let's know the way we relate and put ourselves together. This will not be the end of this gathering. Let's
Yes.
ensure that this program is not a waste. Let's
Yes.
ensure that it form a solid part of our life, and let's make it beneficiaries to others. God will help us in the name of Jesus. Thank you all.
Amen.
God bless.
Amen.
Thank you so much, sir. We appreciate you, sir. Mr. Hafiz, we are so grateful, sir. Thank you so much for
thank you,
all
sir.
you
Thank you, sir, for your time.
do. Our regards to Mr. Sanusi as well.
All right, thank you,
We
sir.
really
Yes,
appreciate that. Our
yes, sir.
regards to your
Thank you,
family as well, sir.
and
All
thank you,
right,
sir.
sir.
Yes, sir.
All right, so. All right. Have a wonderful night rest, everybody.
All right.
Okay.
Yeah,
Thank
you
you,
too.
sir. Thank you.
Okay. Oh. All right, sir. Yes, I
Yes, sir.
appreciate